Good afternoon, everyone. My name is Emily Wall, and I'm an assistant professor in the Computer Science Department at Emory University. I'm really excited to be joining you for this session on equity in science. So today I'm going to talk to you about my work on bias and visualization as a mechanism with which I address equity through my research. Information visualization as a field combines research methods and techniques from human perception and computer science. The field is motivated by information overload, and we learn quite a bit from vision scientists in this regard. Visual perception researchers consider how our attention is allocated in the presence of overwhelming information. Herb Simon, an early pioneer in human-computer interaction research among other fields, says that what information consumes is rather obvious. It consumes the attention of its recipients. Hence, a wealth of information creates a poverty of attention and a need to allocate that attention efficiently among the overabundance of information sources that might consume it. One classic motivating example in visualization is Anscombe's quartet. It's 4 datasets comprised of x and y values, and they share the same mean and standard deviation of x and y values, and a number of other interesting statistical summaries. Using these standard statistical and computational approaches, these datasets are indistinguishable. But of course, vision scientists know that there's value in looking at the data, which quickly reveals starkly different trends in these datasets. And there are a number of other cool tricks that visualization researchers like to show to make the case for why viz is important, like asking how many 3s there are on the screen. It's hard to tell, but once we lower the opacity of the other numbers, we get a pop-out effect, and we can quickly see the answer. We leverage a lot of work from perception and vision scientists, such as the work by Anne Treisman and others on pre-attentive processing, to inform how we will visually encode data for optimal communication. So information visualization is described as the use of computer-supported, interactive visual representations of data to amplify cognition. As Ben Schneiderman put it, the purpose of visualization is insight, not pictures. And visual analytics is related, but focuses on analytical reasoning, facilitated by interactive visual interfaces. In visual analytics, we advocate for the combination of humans and machines, where we think we can get the best of both worlds. Computers give us fast and accurate information processing, while humans give us sense-making capabilities and domain expertise. And we look for the appropriate balance between human and machine efforts by building systems that look something like this, that combine analytics and computations with the power of human perception to facilitate data exploration. But what we haven't really considered until recently is what limitations humans bring to this process. And the key to understanding those limitations is enabled by the fact that people are using systems like these more and more to analyze their data and make decisions. And in my research, I utilize the interactions that people perform in these digital visual environments as a form of data that we can use to make inferences about the person who is performing those interactions. So there's some background on visualization, and you may be wondering at this point what any of this has to do with equity. There are a number of ethical and equitable issues where visualization can help. To give a quick example, consider the 2016 US election. Here's a map where the sizes of the bubbles are proportional to the number of votes received by the candidate who won each county. Red is Donald Trump, and blue is Hillary Clinton. It's not obvious from this map who the victor would be. Here's another map that shows the same data, but each county is colored in geographically by the winner of that region, called a choropleth map. In this representation, there are a lot more red pixels on the screen. While they ultimately utilize the same data, these visualizations tell 2 very different stories. Guess which version was hung in the White House? If you guessed the one that's covered in red and looks like Trump had a landslide victory, you'd be correct. So there are a lot of ways in which visualization can bias people. Data is not neutral, nor are the visual representations of that data neutral. But for every bad actor who may try to manipulate viewers with data, machine learning models, or visualizations, there are hopefully an equal or greater number of well-intentioned people who want to do good things with data. They want to be cognizant of what their inherent biases are and combat them to produce fair and equitable outcomes. In mine and my students' research, we try to facilitate reflective and equitable analysis and decision-making processes through visualization by developing new ways of detecting bias from observable user interactive behaviors and designing systems that will leverage perceptual strengths to help people reflect on their analysis and decision-making processes. There are a number of places where different types of so-called bias can be introduced or propagated, not just relevant to visualization, but more broadly when people are looking at data to make decisions, including scientists such as ourselves analyzing our own data. For starters, the data may be subject to things like sampling bias. We know in academia there's a bias toward weird data. Western, educated, industrialized, rich, and democratic people are far overrepresented in research. And once that data is fed into machine learning models, it may be further subject to a different set of biases. For instance, facial recognition models used by top tech companies predict gender less accurately for people with darker skin. Similarly, when data is fed into a visualization, the choice of visual encodings and the mechanisms for interacting with or rendering the data can also introduce biases, like the election map example that I showed earlier. And when models and visualizations combined are used to help people make decisions, they are further subject to the biases of the decision maker, including cognitive biases, perceptual biases, and societal biases that may be implicit or ingrained as a result of social and cultural norms. These are all different notions of the same term bias. So how do we unify them, try to understand them in context of one another, and leverage finding from each field to help decision makers at the end of the pipeline? Again, in my research, the goal is to facilitate reflective and equitable analysis and decision-making processes. We do that by developing ways to detect bias. We can measure bias using fairness metrics from machine learning, computational bias metrics based on user interactive behaviors, by visual attention with eye tracking, and so on. And we can develop strategies to mitigate those biases through visualization system design. For the most part, existing bias mitigation strategies typically rely either on educating people about biases beforehand or involve potentially cumbersome strategies for people to carry out and manage mentally. But there really isn't much technological support for mitigating biases in real time while people are interacting with data. So a lot of my research has sought to explore the question, how can we design systems that increase user awareness of biased analysis processes? As one example, my collaborators and I built a system that visually represents interaction traces, which show a user's own previous interactions with the data to increase their awareness of past analysis behaviors that might influence their future analyses. That includes things like coloring the points in the scatter plot based on how much you have interacted with them, or comparing the distribution of the underlying data to the distribution of user interactions. And we sought to understand how interaction traces impact user behavior, decision-making, and awareness of unconscious biases through a series of in-lab and crowdsourced experiments, comparing a system with and without interaction traces, with tasks in the domains of politics and movies. For example, the political task instructed participants to use the visualization system to explore a dataset and choose a committee of 10 fictitious politicians to review public opinion on the recent Georgia House Bill 481, which banned abortion in Georgia after 6 weeks. We expected to observe things like bias toward a particular gender, bias toward a user's own political party affiliation, bias toward a specific age group, and so on. I won't go into details of the study, but ultimately we found mixed support and will need to run additional experiments. But interaction traces look to be a promising approach for increasing user awareness of unconscious biases. One reflection from our experiments is that the accuracy of our ability to quantify when biased behaviors are happening has limitations. It's difficult to be prescriptive about what constitutes ideal behavior or decisions because it's so context dependent. Instead, using visualization and interaction design to cause the user to take a moment of conscious reflection is far more valuable. And finally, there's a trade-off to increasing people's awareness of potential biases. It comes at the cost of increased cognitive load, certainly, and you may empower people to make more informed and conscientious decisions, but you may also just be giving them ammunition to amplify their conscious biases. One application that my student and I are currently working on is in the context of graduate admissions. We began the project to improve equity in our own departmental admissions processes by mitigating reviewer biases using visualization. And it also touches on some big research questions in visualization and data-driven decision-making. In the past, our graduate admissions process looked something like this: a committee of faculty infinitely scrolling through one long PDF document that represented one applicant's portfolio. But this is problematic for a number of reasons. This is hard to navigate, error-prone, and bias-prone. So my student, Yanan Da, is working on a system that leverages visualization and interaction traces to improve equity in the admissions process. It shows interaction traces of each reviewer's own attention across the applicants and can be compared against that of other reviewers to increase awareness of implicit biases before potentially bad or inequitable decisions are made. We hope to use it in this year's graduate admissions cycle. Now, in addition to research, what are some practical steps you can take to improve equity as an early career researcher or otherwise? You'll hear from William next about open science initiatives. And then you'll hear from Walter about accessibility at conferences, but there are also a number of other ways that you can take action. Start conversations at your institution and in your research community about equity, accessibility, and push to ingrain that in the culture. Importantly, involve everyone in those conversations. There's a lot of power to set the tone of departmental or community culture when you have allies. Advocate for democratic processes. This year, my primary research community at IEEE Viz held its first election so that people nominated and voted for by the community would serve on the steering committees. There are a lot of people in the community that care about improving diversity, equity, and inclusion, and things can improve when there are processes in place in the community to make those voices heard. Review with equity in mind. It's easy to squash the ideas of people because it doesn't suit your idea of how the research should have been done. That's not to say that I'm advocating for subpar research, but you should keep this in mind, the fairness and the delivery of your critiques, so that you aren't creating an unfriendly climate. Be an advocate, particularly those who are in positions of privilege and power. Don't leave all of the burden to your colleagues who are most affected. Be a voice that advocates for cultures and practices that will focus on retention of diverse people and mindsets. Be an advocate for your students and collaborators. In a position of power, you have the ability to advance their careers by letting them speak for themselves, giving them credit and spotlight, and giving room for others to speak by keeping in mind power dynamics. And last but not least, I hope that I have also shown you that you can work on problems that will improve equity directly through your research itself. Steer your research toward addressing problems that matter to you. Choose your collaborators wisely to incorporate voices and opinions that ought to have some weight. For many of you, this will seem like obvious advice. That's great. But if it doesn't, then I encourage you to think about these very deeply. Thank you all for your attention, and thank you to my students Yanan, Ziwei, and Xiao for their work on these projects. I'm happy to take any questions now, or feel free to shoot me an email to keep the conversation going. And if you find this work interesting, there's a community of people focused on the intersection of data visualization and vision science, so check out vizxvision.com.